As far as GATE exam is concerned, the most important topic from radiation is the view factor. And a numerical theoretical question कई बार आप देखोगे रेडिएशन से जो आएगा वो व्यू फैक्टर पे बेस्ड होगा, राइट? तो ये जो लेक्चर होगा दैट विल बी इंटायरली अबाउट व्यू फैक्टर्स. आई विल टेक न्यूमरस एग्जांपल व्हिच विल मेक यू द कॉन्सेप्ट ऑफ व्यू फैक्टर वेरी क्लियर. प्लीज नोट कि आपको इस डिस्कशन में जो रूल्स बताऊंगा फॉर फाइंडिंग द व्यू फैक्टर्स, इसके अलावा no rule, I mean if you follow a standard book you will find a lot of other rules are written there. There are various tables also. वो सब बिल्कुल नहीं पढ़ना है आपको, बस इन रूल्स के हेल्प से जो भी व्यू फैक्टर फाइंड कर सको वही क्वेश्चन सॉल्व करना है. If you are solving a problem, if someone is giving you a problem which cannot be solved by using these rules, then that is not in your scope. उसको आप सीधा छोड़ दो, ठीक है? क्योंकि व्यू फैक्टर के टेबल्स होते हैं, ठीक है? उसमें कुछ नहीं है, वैल्यूज दी है आपको, वैल्यूज देखनी है and then you have to find the view factors. First of all, let's say that there is a surface I, a random surface I, okay, and a surface J. दो surface है, right? I और ये जो I surface है इसको भी मैं diffuse, देखो हम लोग जो भी discussion करेंगे हमारे जो surfaces होंगे वो diffuse ही होंगे. Always diffuse means radiation is emitted from a surface in all the directions. ठीक है? So we are not talking about spectral surfaces, only diffuse surfaces. Suppose we have I and J surfaces, right? Now you know that this is a diffuse surface. It is going to emit radiation in all the directions, right? Now the radiation which is leaving the surface I, right, like this. The radiation which is leaving surface I, all of this radiation will not be able to reach surface J. Fine. So it is very obvious that the total radiation which is leaving surface I, the total radiation which is leaving surface I, only a fraction of it which is leaving surface I slash a dash, only a fraction of it is reaching surface J, right? Reaching surface J. Okay. So I surface से जितनी भी रेडिएशन निकलेगी उसका केवल एक फ्रैक्शन, हाँ, it is possible that this fraction is equal to 1 or this fraction is equal to 0, right? But let us take a general case that the total radiation which is leaving surface I, only a fraction of it is reaching surface J or it is intercepted by J. मतलब I से जितनी रेडिएशन निकली उसका केवल एक छोटा सा फ्रैक्शन, उसका एक पार्ट was intercepted by J, right? So to denote this we write view factor, we denoted by Fij. अच्छा, व्यू फैक्टर के दूसरा नाम जो है शेप फैक्टर या ज्योमेट्री फैक्टर है, राइट? सो व्यू फैक्टर आर आल्सो नोन बाय द नेम ऑफ शेप फैक्टर और ज्योमेट्री फैक्टर, कॉन्फ़िगरेशन फैक्टर, ये सारे नाम है. बट व्यू फैक्टर और शेप फैक्टर के अलावा बाकी नाम नॉर्मली यूज में नहीं लिया जाता है, ठीक है? ज्योमेट्री फैक्टर और क्या नाम बताया एक आपको, कॉन्फ़िगरेशन फैक्टर. All of them are same as the view factor, but the view factor is the most commonly and the standard used configuration. ये C नहीं होना चाहिए, configuration factor. आपको view factor ही नाम यूज किया जाएगा, लिख लेना सारे नाम, कोई बात नहीं. FIA से डिनोट किया जाता है, it is the fraction of radiation, comma, ठीक है? ये एक लाइन हो गई, fraction of radiation leaving from surface I, which is intercepted by surface J, So I से जो रेडिएशन निकली उसमें से कितनी रेडिएशन J ने इंटरसेप्ट की, that is called view factor. Now definitely the value of Fij should be between 0 to 1, including 0 and 1. Means it can be 1 also. Means all the radiation leaving surface I is intercepted by surface J. ठीक है? अब जो क्वेश्चन गेट में आते हैं, they are mainly based on the properties of these view factors. So first of all, it lies between 0 to 1. Okay. Secondly, there are some rules, there are some properties. देखो, एक तो तरीका ये कि आपको व्यू फैक्टर डायरेक्टली बता दिया जाए, राइट? बट समटाइम्स there are some rules which can be very useful to find the view factor in many cases. So let me take one by one all those rules. The first one, this is not a rule, this is a kind of by inspection. अब इंस्पेक्शन करना एक रूल नहीं होता, बट आपको बता रहा हूं कि बाय इंस्पेक्शन यू कैन फाइंड द व्यू फैक्टर, बट नॉट ऑलवेज, ओनली इन सम केसेस. फॉर एग्जांपल अगर मैं इसको लिखूं तो बाय सिमेट्री, क्योंकि इंस्पेक्शन एक्चुअली सिमेट्री एंड इंस्पेक्शन दे डोंट हैव द सेम मीनिंग, राइट. बट इंस्पेक्शन में आप एक्चुअली क्या इंस्पेक्ट करते हो? यू इंस्पेक्ट अबाउट द सिमेट्री ऑफ द ऑब्जेक्ट, और ज्यादा चीजें आप इंस्पेक्ट नहीं कर सकते. एंड इट इज नॉट ऑलवेज द केस दैट यू कैन फाइंड अ व्यू फैक्टर बाय इंस्पेक्शन. In some cases you can find, in some cases there is no use of symmetry. Symmetry समझते हो ना? Symmetry. Suppose I'll take an example. For example, okay, by inspection or symmetry, like let me take an example of a pyramid kind of structure whose base is a square, right? Pyramid kind of structure whose base is a square. Right, suppose this is a square base, right? I'll try to make a proper pyramid kind of structure. Okay, no, this is not. No, it is not looking like a pyramid. So it should look like it is symmetrical. Okay. We have actually how many faces? We have 4 faces, right? Are you getting this? Have you seen a pyramid? A pyramid has how many faces? I think it has 4 faces, right? And apart from those 4 faces, suppose I have a square base. पहले base ही बना लेते हैं लोग. I have a square base, okay? I have a square base, and then I'm just giving you an idea that this can be the case of a symmetrical object. कोशिश की है मैंने बनाने की. आई होप आपको समझ आ रहा होगा दैट इट्स अ सिमेट्रिकल ऑब्जेक्ट, राइट. अगर नहीं आ रहा तो इसको और थोड़ा सा छोटा कर देते हैं, ठीक है? थोड़ी सी फीलिंग आपको और आ जाएगी इसमें. राइट, sort of. This is a kind of pyramid which is having triangular faces, and how many faces? 4 triangular faces and a square base, right? And a square base. Suppose that in this case I'm naming the base as the surface 1. Actually heat transfer में आप surface के names रखोगे in finding the view factors. This is surface 1. The right side is F2, the left side is 3, the back side is 4, and the front side triangle is 5. I hope you are getting that how I have named this, right? So there are total 5 sides, right? But अगर आप खुद को स्क्वायर की तरह ऐसे लेटा जाओ, अगर आप खुद लेट जाओ यहाँ पे, that you feel that you are the square, and you are like this, and you look at all the 4 faces of this shape, you will find that each of the face appears identical to you, right? If it is a square and you imagine yourself that you are lying on that square with your face upside, right? You are going to find that each and every shape will be symmetrical. Each and every side of this pyramid will look same to you. You can't differentiate. Of course, you can say that this is my right and this is my left, but you'll feel that same kind of things are there, right? Suppose I'll give one more example. Don't worry. So in this case, whatever radiation will leave the surface 1, the same fraction of that radiation will reach surface 2. The same fraction of that radiation will reach surface 3, the same fraction of that radiation will reach surface 4, and the same fraction of the radiation will reach surface 5. All of the view factors will be equal. This is a kind of inspection, this is a kind of symmetry, right? But obviously, if you say that, sir, if I see with respect to phase 5, now for phase 5, all the faces are not identical. Some of them may be, but all of the faces are not identical. ठीक है, हर फेस के लिए ऐसा नहीं होगा. This is a symmetrical body with respect to the square base only. If you imagine that you are the square base, you will find that all the 4 sides are appearing same to you. So that is why the radiation which is leaving the surface 1, equal fraction of the radiation will reach all the 4 faces, and all of them should be equal. Let me give you one more example. Suppose that I have a cube. अब क्यूब बनाने की हैबिट है तो काफी आसानी से बन जाएगा. Suppose that I have a cube. Okay. It's not a cuboid, this is a cube. Even if it seems that it is a cuboid, imagine that it's a cube. कर लोगे imagine? नहीं कर पाओगे. आओ थोड़ा सा और इसको. I'm not very good at drawing these things. और आज और भी बिल्कुल नहीं बन रहे मेरे से. So okay. Suppose this is a cube. Right, all the edges are same. Let me name the surfaces. I can name the surface as, okay, the surface 1 is the base, correct? How many faces are there? There are 6 faces total, right? Surface 1 is base, top surface is surface 2, and 3, 4. Are you getting this? This is the right face, this is the back side face, this is the left side face, and this is the front face. 6. Now what do you think? If I ask about surface 1, आप surface 1 हो, what do you think? That the radiation which is leaving surface 1, for the surface 1, how many faces are symmetrical? Or is there no face which is symmetrical? क्या लगता है कोई symmetrical है भी कि नहीं है? आप imagine a cubical cube shaped room, right? If you're lying on the floor, for you all the walls are same. If I talk about this room is, I think this is 9 and this is 9 by 12 room, right? Because this board is of 8 foot, तो ये जो room है आपका 9 foot का होगा approximately. This room is 12 by 9. So if I lie on this floor, for me this is having a dimension of 9 while this is having a dimension of 12. So these two walls are not identical, right? But if I'm lying on this floor, the wall on this side, which is in the length, having a length of 9 and having a length of 12 and height of 9 or 10, and this side wall, they are symmetrical. So the radiation leaving from the surface, equal part of the radiation will reach this and this. मैं नहीं कह रहा कि वो इसके भी बराबर होगा, but यहां जितना फ्रैक्शन जाएगा उतना ही फ्रैक्शन यहाँ जाएगा, right? Similarly, you see here, for the surface 1, the radiation which is leaving surface 1, equal fraction of the radiation will go to surface 3, surface 4, surface 5, and surface 6, because all the 4 walls are similar, will appear similar to a person who is lying on the, but not the roof. By roof same, by roof की orientation अलग है ना. Roof is like this. Roof is like this. See, the walls are present like this. Wall, you are lying here. Wall, 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 wall. For you, the walls are same. But the top surface is totally in a different orientation. So that should not be included here. The radiation leaving to all these surfaces 3, 4, 5 and 6 will not be equal to the radiation leaving, the fraction of radiation leaving to surface 2. Fraction of radiation leaving to surface 2 will be entirely different from the fraction of radiation leaving to surface 3, 4, 5 and 6. Okay, there can be numerous other examples, right? There can be numerous other examples. Okay, तो symmetry आपको inspection से देखनी है. कई सारे ऐसे क्वेश्चंस लूंगा जहां मैं आपको इजीली सिमेट्री बता दूंगा और आपको थोड़े से क्वेश्चंस करने के बाद प्रैक्टिस हो जाएगी इस चीज की. ठीक है, केमिकल इंजीनियरिंग में जो क्वेश्चंस आते हैं आपको देयर विल बी वेरी लेस वेरी लेस फ्यू टाइम्स यू विल बी यूजिंग दिस सिमेट्रिक कंडीशन, क्योंकि आ जाता है क्वेश्चन तो बच्चे वैसे ही फंस जाते हैं कि सिमेट्रिक है कि सिमेट्रिक नहीं है. यहाँ पे थोड़ा सा आपको अपनी इमेजिनेशन यहाँ पे डेवलप करनी होगी टू फाइंड वेदर अ सिस्टम इज सिमेट्रिकल और नॉट. सो दिस इज टोटली बाय इंस्पेक्शन. दैट इज वाई इसको मैंने लिखा कि बाय इंस्पेक्शन you can, अच्छा, can you find the values? You'll say कि सर values तो पता नहीं लगी. Yes, values अभी पता नहीं लगी है. For finding the values there are other rules. आपको बाकी सारे rules भी समझने पड़ेंगे. But I gave you 2 examples, right? One was the pyramid with a square base and another is a cube. If you take the example of a cuboid, like I was giving the example of this room, but suppose this room is having a dimension of बना ही लेते हैं इसको भी. Suppose I have a cuboid. This is the cuboid. I am making this cuboid according to the dimension of this room. Okay. Right. So this dimension and the height of this room, they are almost same, but the length is different. Right? The length is different. Okay. Let's say that this dimension is 9. This dimension is 12. Right? 9 by 12. while this dimension is 9 or 10. Let's take a different case. It's a cuboid. Let's take 10. What do you think? If I say that this surface is surface 1, the base of this room, the floor of this room is surface 1. To the surface 1, how many faces will appear to be symmetrical? भाई इस सरफेस से जो रेडिएशन निकलेगी, इस सरफेस के लिए द फ्रंट फेस एंड द बैक फेस, these two are symmetrical, but symmetry of one side, ये अलग तरह से symmetrical है, and this, the left face and the right face, they are also symmetrical, but symmetry of a different kind. भाई symmetry में भी symmetry है ना? The front face of this cuboid, because it is 9 by 10, this is 9 by 10, to this floor, this front face and the back face will appear to be symmetrical. तो यहां से जो रेडिएशन निकलेगी, सपोज यहां से रेडिएशन निकली 10, उस 10 का 1%, 10%, suppose 10 का 10% is 1. So out of 10, 1% means 1 will go to this front wall and therefore 1 will go to the back wall. But out of 10, it is possible कि जो left side की wall है यहाँ पे 2 जाए, और अगर यहाँ 2 गया तो यहाँ भी कितना जाएगा 2. So इस diagram में there is a symmetry, but the symmetry of two types symmetry is there. One is the front wall and the back wall symmetry, and then the left wall and the right wall symmetry. Top is not symmetrical. राइट इस तरह से आपको इंस्पेक्शन से डिसाइड करनी है कि जो फेसेस हैं वो सिमेट्रिकल हैं या नहीं है. देयर आर ओनली फ्यू रूल्स. ये व्यू फैक्टर्स के लिए आपको मैं कुछ ही रूल्स बताऊंगा. लोग इस पर कई बार टाइम स्पेंड नहीं करते ज़्यादा, लेकिन ठीक है, जितना टाइम चाहिए हम उतना ज़रूर स्पेंड करेंगे, जो भी हमारा ये 1 आवर का लेक्चर होगा. ठीक है, तो ये इंस्पेक्शन से एंड प्लस देयर आर सम अदर रूल्स, उनका यूज करके आई कैन फाइंड द व्यू फैक्टर. सो बाकी के रूल्स क्या है वो भी डिस्कस करते हैं. इन इंस्पेक्शन ओनली देयर इज वन मोर रूल, उसको हम लोग इंस्पेक्शन की कैटेगरी में डाल सकते हैं. ठीक है, सो आप उसको फर्स्ट रूल में लिख लो, बाय इंस्पेक्शन सिमेट्री, एंड देन बाय इंस्पेक्शन लिखो सेल्फ व्यू फैक्टर. ये नाम दिया जाता है कई बार, सेल्फ व्यू फैक्टर, खुद से खुद को देखने का फैक्टर. इफ यू सी योरसेल्फ, then what is the factor? Means in this by inspection only, let us write by inspection and slash self view factor. Self view means suppose the surface is there and radiation is leaving the surface. What fraction of the radiation leaving a particular surface is reaching the surface? अब आप बोलोगे सर ऐसा हो सकता है क्या कि एक सरफेस से निकलती हुई रेडिएशन क्या घूम के उसी पे जाएगी? सो द आंसर इज अ सरफेस इज नेवर नॉट ऑलवेज फ्लैट, राइट? सो व्हाट इज द मीनिंग ऑफ सेल्फ व्यू फैक्टर? राइट फैक्टर हियर, फैक्टर द फ्रैक्शन ऑफ रेडिएशन, द फ्रैक्शन ऑफ रेडिएशन लीविंग द surface I, the fraction of radiation leaving the surface I, surface I is the name of surface, I, J कुछ भी नाम दे सकते हैं, leaving surface I which is intercepted by the surface I, right? Which is intercepted by surface I, okay? Intercepted by surface I, correct? So I से निकलने वाली रेडिएशन जो I तक पहुंच जाए, जितना फ्रैक्शन पहुंच जाए, that is called self view factor, and it is denoted by FII or FJJ if the surface name is J. For example, suppose if the surface is a flat surface, in radiation you have this kind of symbol. It means that only this surface is included in the radiation and this surface is not included. Okay, now suppose that this is a flat surface. A flat surface से जितनी भी radiation निकलेगी, it will never come back to the surface because the radiation cannot take a U-turn and then come back to the surface again. Right, so जो भी surface से जिस direction में भी you have this radiation, it is going to only leave the surface and going to intercepted by another surface. So if you ask me that, sir, what is the self view factor for a flat surface? So for this case, FII is equal to 0. ये inspection से ही पता लगेगा ना, there is no, this is inspection. That is why I have put this in the category of inspection. That for a flat surface, self view factor is 0. अब खुद को imagine करो that you are lying on a floor with your eyes straight in the direction of the sky, right? Can you see yourself in that case? No, definitely not. So self view factor is 0. Suppose that this is a convex surface, right? And this side there is no effect of radiation, so only the upper surface is involved. Now in this case also the radiation will be leaving like this. It is also, मैंने आपको बताया ना हर चीज, this is a diffuse surface, so in all the directions the radiation will be leaving. In any case, you can see that the leaving radiation cannot strike the surface, right? Convex surface also. So in this case also FII, the self-view factor is equal to 0. But if you have a concave surface like this, अब आप देखोगे कि that for a concave surface, it is possible that the radiation leaving a particular surface, suppose from here the radiation is leaving, okay? Of course, because it is leaving in all the directions, right? Now you see that this radiation can be intercepted by the same surface. This radiation can be intercepted by the same surface, while this radiation cannot be intercepted. Suppose this is the surface, right? Cannot be intercepted by the surface. Similarly, if from this point, suppose radiation is leaving, right? This cannot be intercepted by the same surface, but right, the radiation which is leaving here from this from the same surface is intercepted by the same surface. So for a convex surface, if you talk about the self-view factor, then definitely it will be non-zero. बोलोगे कि सर कितना होगा, फिर पता नहीं कितना होगा, but definitely it will be non-zero. तो inspection से आप ये चीजें बता सकते हो. Self-view factor, that is one thing, and symmetry. This is called inspection rule. Inspection से और कोई चीज नहीं, अब नहीं, बस self-view factor और symmetry. इसके अलावा कोई रूल और होगा, in that case वो क्वेश्चंस आपको नहीं सॉल्व करने हैं. जो भी क्वेश्चंस में आप इंस्पेक्शन से चीजें पता कर पाओ, that is fine. That is one rule, inspection. What is the next rule? Is called the reciprocity theorem. Very very important, because वही एक रूल आपको भी पता होगा कि हाँ reciprocity theorem is there, right? आपने कई बार यूज भी किया होगा. So one is reciprocity theorem and another one is the summation rule. Then we have superposition principle, right? So reciprocity theorem and summation rule and superposition principle. These are the three more rules which can be used for, okay. So write down the third rule. So note कर लिया होगा आपने, नहीं तो बैक जाओ, पॉज करो, नोट करो. I'm erasing this part. Okay. So reciprocity theorem is applicable for any two bodies, right? Third one is reciprocity theorem of radiation. Reciprocity, छोटी सी 2 लाइन की डेरिवेशन है, doesn't matter. Reciprocity theorem, okay. Reciprocity theorem of radiation, which says that for two surfaces, this is only applied between two surfaces. Means I'm not saying that there should be two surfaces. There can be n number of surfaces, doesn't matter, right? But एक बार में reciprocity theorem always applies between two surfaces. एक बार में केवल दो surface के बीच में आप reciprocity theorem लिख सकते हो. I'll tell you how. Right? For two surfaces, I and J, you can write AI means area of surface I into Fij must be equal to AJ into Fji. Right? This is the reciprocity theorem. Correct? अब आपके पास suppose you have, and see this theorem is applicable to any two surfaces. ऐसा जरूरी नहीं है कि they make an enclosure. Enclosure, you understand? A closed enclosure, enclosed surface, enclosed body, right? ऐसा कुछ हो, ऐसा जरूरी नहीं है. It is applicable to any two surface, right? Now the second thing is, suppose you have n surfaces. Suppose you have this kind of n surfaces, right? I'm not saying that they must be enclosures. They can be enclosure, they cannot be enclosure. In any case, reciprocity theorem is valid. Suppose you have this surface also. Suppose you have this surface also. Right? Let's say you have n surfaces, a total of n surfaces. Right? Now, in this case, you can take any two surface and write a reciprocity relation. For two surface, see, for this two surface, one relation. For this two surface, one relation. Two relations. For this two surface, one relation, so 3 relation. For this two, one relation, so 4 relation. And for this two, one relation, so 5 relation. And I think for this two also 6 relations. A total 6 relations, 6 reciprocity relations can be written for these 4 surfaces. कितने relations लिख पाओगे? For n surfaces, how many reciprocity relation? भाई, out of n you have to make a pair of 2. Select करना है, दो चीजों को select करने के out of n objects, how many ways are there? NC2. NC2 reciprocity relations, because reciprocity relation is written between two surfaces. So out of n surfaces, you have to select a pair of 2. So how many pair of 2s can be selected out of n surfaces? So NC2 reciprocity relations. Please note, it is not mandatory that for writing reciprocity relation, the object, the surfaces should form an enclosure. This is not mandatory. If they are forming enclosure, still reciprocity theorem can be written. If they are not forming enclosure, still reciprocity theorem can be written. Okay, so if there are n surfaces, आप n surface में से दो nc2 surfaces, so there will be nc2 reciprocity relations. Fourth, summation rule. These two will be frequently used in chemical engineering problems, in mechanical engineering problems. In mechanical engineering, even symmetry is used, right? And in their branch there is some more detail of these rules. एक string rule भी होता है, ठीक है? तो string rule आपको नहीं पढ़ना, don't worry, right? Summation rule is there. Okay, so summation rule says it is only applicable for enclosure, right? For an enclosure. अब यहाँ पे ये word important है कि summation rule आप enclosure पे ही लगाओगे. For an enclosure. This restriction is not there in case of reciprocity relation. Reciprocity relation आप कहीं भी लगाइए, लेकिन summation rule enclosure पे ही लगेगा, right? For an enclosure, let's say I have this kind of enclosure. मैंने ऐसी random enclosure बनाया. That enclosure can have any kind of shape, right? It's not always a hexagon or pentagon. It's not like that. Suppose we have n number of surfaces in the enclosure, and only the inner surfaces are taking part in the radiation. Okay, suppose these are the surfaces. Okay, suppose n surface enclosure is there. This is surface I, this is surface J, this is surface K, and dot 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 dot. There are n surfaces, right? For an enclosure of n surfaces, आप कोई भी एक surface पकड़ो, right? Suppose I am taking surface I. Now the fraction of radiation which is leaving surface I and reaching surface J, some fraction will reach surface J. The fraction of radiation which is leaving surface I, right, and reaching surface K. The fraction of radiation which is leaving surface I and reaching surface L. The fraction of radiation which is leaving surface I and reaching surface M, and so on, small n, and suppose I have total n surfaces. So the fraction of surface I, fraction of radiation leaving surface I and reaching surface n, all of that must be equal to 1. 0 या 1? 1, because the sum of the fractions of all the radiations leaving surface I must be equal to 1. अब आप बताओ ऐसे कितने relation लिख सकते हो? See, for I, for one surface you have one relation. For the other surface you will be having one relation, that the fraction of radiation leaving surface J, which is reaching surface I, the fraction of radiation which is leaving surface J and reaching surface J, of course this will be 0 in this case, लिख देते हैं, because from the inspection part, here also you can write FII, that will be 0. The fraction of radiation which is leaving surface J and reaching surface K, the fraction of radiation which is leaving surface J reaching surface L, and so on, the fraction of radiation which is leaving surface J and reaching surface N, sum must be equal to 1. कितने relations लिखोगे? For an enclosure of n surfaces, there will be a total of n relations. ठीक है? So for an enclosure of n surfaces, you can write n summation rules and nc2 reciprocity relation. ये आपको normally books में लिखा हुआ नहीं मिलेगा. हाँ, कोई बहुत बड़ी बात नहीं है, but इस पर कई बार आपका ध्यान नहीं जाता है कि हाँ सर, अगर n surface enclosure होगा तो कितने summation rule लिख सकते हैं, and for n surfaces how many reciprocity theorem we can write. अब summation rule का, reciprocity theorem का, and that inspection definitely. अब अगर आपको मैं tetrahedron की बात करूं, जो I was taking an example, no, tetrahedron, because tetrahedron means I think 4 faces. There were 5 faces. Pyramid बोल लेते हैं उसको. If I talk about that pyramid which I was discussing few moments before, so this was the case, right? Okay, this was the case. Okay, suppose I think हर बार फिर इसको थोड़ा सा actual look देने के लिए ना इसको थोड़ा सा छोटा करना पड़ेगा. Assume that this is a square. Okay, assume it is square, and this looks like, okay, tetrahedron. I was saying that in this case, if this is the surface 1, the square base is assumed as the surface 1, then all the view factors from surface 1 to 2, surface 1 to 3, surface 1 to 4, surface 1 to 5, all of them are equal from symmetry. And I also know that because this is also an enclosure, right? So I can write that F11 plus F12 plus F13 plus F14 plus F15 must be equal to 1. This is summation rule. Here you can write JAII also. You can add FII. Okay, we have to start with II. Okay, FII. हाँ, इसको miss नहीं कर सकते. Please write this. Otherwise, it will be a mistake. अगर मैं यहाँ पे II नहीं लिखता हूँ, it will be a mistake because every time it's not necessary that FII will be 0. This is a plane surface, so II was 0, right? So this is symmetry. This is summation rule, and by inspection, the self view factor of surface 1 F11 because it's a flat surface, it must be equal to 0. अब यहाँ से आप बताओ कि ये view factors कितने आएंगे? You can see here that all of them are equal, right? All of them are equal, and therefore the answer for this is all of the view factor F12 equal to F13 equal to F14. कितना आ जाएगा? बिना कुछ किए ये सारे व्यू फैक्टर्स किसके बराबर होंगे? 0.25. आप इसको एज अ क्वेश्चन ट्रीट करो that there is a surface, there is a pyramid kind of shape where the base was a square. Right, these are some basic rules which can be used in these finding the shape factors. One more is remaining, which is less frequently used in gate, in chemical as well as in mechanical. That is called superposition rule. That is not used frequently, right? But still, आपको पता होना चाहिए that there is a superposition principle in radiation. इसके अलावा अगर आपको कुछ और चाहिए, then that has to be provided in the form of tables, right? Inspection, symmetry, self view factors, summation rule, and then this summation and reciprocity relation. Apart from this, if something else is required, then it must be directly provided. That F11 is equal to this, F13 is equal to this. इस तरह से आपको directly provided होना चाहिए. Suppose that we have, okay, you can write this one. This is called superposition principle. Superposition principle. ठीक है? Superposition principle. Okay. So in this case, suppose I have a wall and it is made up of, this is area A1, this is area A2, this is surface 1, this is surface 2, and then I have, you might have seen this kind of diagram in many books, many standard books, okay, and this is surface 3, right, having area A3, let's say A3, okay. So if you want to calculate, let's say that you want to calculate the the fraction of radiation which is leaving surface 3 and reaching surface 1, right? You know that the fraction of radiation leaving surface 3, that is f of 3, and which is reaching, let us say that, for the moment, let us assume that this is a single surface, and let us name this as the surface 4, okay? So you can say that the fraction of radiation which is leaving surface 3 and entering surface 4 is equal to the fraction of radiation leaving surface 3 and reaching surface 2 plus the fraction of radiation leaving surface 3. आप बोलोगे कि सर ये तो काफी लॉजिकल सा है, इसमें रूल क्या है, बट अब यही है सुपरपोजिशन रूल. यू कैन राइट लाइक दिस. अब अगर आप इसको surface 4 मान लो and then you can write like this. Okay, so F34 is equal to F32 plus F31. This is surface 2. This is surface 1, and then you can write the reciprocity relation. Obviously, you can write the reciprocity relation between these two, right? Suppose you can say that AI Fij means, suppose you consider this as a single surface, so you'll write that A3 F34 is equal to A4 F43, correct? And what is A3? A3 is A3, okay? F34 can be written as F32. So F34 can be written as F32 plus F31. What is A4? A4 is A1 plus A2, right? So A1 plus A2, and then you can write F43. What is 43? Can I say that F43 is the fraction of radiation leaving surface 1 and reaching surface 3. So you can say that this is F43 is F13, ये हाइफन लगाते हैं कई जगह नहीं भी लगाते, प्लस F23. I mean I can expand like this. Various इस तरह के रिलेशंस बना के आपके पास क्वेश्चंस आ सकते हैं. इसमें न्यूमेरिकल कम आते हैं, बट सपोज आपको कोई ऐसा सरफेस दे दे एंड देन दे आस्क यू दैट व्हिच ऑफ द फॉलोइंग रिलेशन इज करेक्ट. This is called superposition principle. The superposition principle, symmetry relations, and और क्या बताया आपको, reciprocity relation, then you have this summation rule, okay, and self view factors. ये 5 चीजें आपके पास. इन 5 के अलावा अगर आपको किसी और चीज की जरूरत पड़ रही है for solving a view factor problem, means you have to completely ignore that question. I mean not in GATE but in practice. अगर आपने यहाँ वहाँ टेस्ट सीरीज आप लोग ज्वाइन करते रहते हो, वहाँ पे इस तरह के क्वेश्चंस अगर आपको मिलते हैं, इट मींस यू हैव टू कंप्लीटली इग्नोर इट. एक्चुअली मेनी ऑफ यू आर स्टिल नॉट क्लियर दैट व्हाट यू हैव टू रीड एंड व्हाट यू हैव टू स्किप. अभी भी कई बार क्वेश्चंस आते हैं, बच्चे इधर उधर के क्वेश्चंस लेके भेजते हैं मुझे कि सर ये सिलेबस में है क्या, ये सिलेबस में है क्या, एंड स्टिल आई डोंट नो व्हाई इन मेनी टेस्ट सीरीज पीपल हैव इंक्लूडेड इररिलेवेंट काइंड ऑफ क्वेश्चंस. ठीक है, तो बस जबरदस्ती आप उसको मुश्किल बनाने के लिए या ये दिखाने के लिए भैया आपने तैयारी नहीं की है, दे आर इंक्लूडिंग सम इररिलेवेंट क्वेश्चंस. ठीक है ना, एंड दैट इज समथिंग यू शुड नो दैट ओके दिस पर्टिकुलर थिंग. आपको जो मैंने बता दिया कि ये नहीं अगर होगी तो हम लोग डेफिनेटली इसको पढ़ेंगे, नहीं है आप उसको छोड़ दो चुपचाप, डोंट वरी. ठीक है, अपने पास टेस्ट सीरीज में बहुत बढ़िया और बहुत रिलेवेंट क्वेश्चंस डले हुए हैं, आप उनकी प्रैक्टिस करो, असाइनमेंट्स की प्रैक्टिस करो, प्रीवियस ईयर की प्रैक्टिस करो, एंड लीव एवरीथिंग असाइड, कोई दिक्कत नहीं होगी. ठीक है, सो दीज आर द बेसिक रूल्स. नाउ आई एम गोइंग टू टेक फ्यू प्रॉब्लम्स ऑन फाइंडिंग दी शेप फैक्टर्स. एक ही साथ में सारी प्रॉब्लम्स मैं लिख दूंगा, आपको सारे में शेप फैक्टर्स फाइंड करने हैं, ज्यादा टाइम नहीं लगेगा. करीबन मेरे पास 7-8 प्रॉब्लम्स है, अच्छी सिलेक्टेड प्रॉब्लम्स है, आपको मजा आएगा सब में शेप फैक्टर फाइंड करने में. आई हैव टेकन 4 एग्जांपल्स. ठीक है, एंड दीज एग्जांपल्स आर नॉट वेरी सिंपल काइंड ऑफ एग्जांपल्स जो आपको गेट के प्रीवियस ईयर में मिलेंगे. आई गेस इनमें से कोई एक आया जरूर होगा, इन केमिकल और मैकेनिकल के हैं, आई गेस मैकेनिकल में आया है, बट आई हैव सिलेक्टेड फ्यू वेरी गुड एग्जांपल्स ऑन व्यू फैक्टर्स जो आपको जो रूल्स मैंने बताया उसकी एप्लीकेशन को क्लियर कर देंगे. ठीक है, फर्स्ट ऑफ ऑल लेट मी एक्सप्लेन दैट वी हैव टू फाइंड द पर्टिकुलर व्यू फैक्टर्स F12 F21 in these 2 cases, right? In this case I have to make the entire view factor matrix. I'll tell you about the view factor matrix, and in this case also I have to find F12 and F21. First of all, please understand, I told you that whenever there is a शेडिंग का मतलब होता है कि शेडिंग दैट साइड सरफेस इज नॉट इन्वॉल्व्ड इन हीट एक्सचेंज बाय रेडिएशन. तो शेडिंग के नीचे जो सरफेस है, आई मीन दैट सरफेस व्हिच इज नॉट शेडेड, दैट इज इन्वॉल्व्ड इन रेडिएशन. सेकेंडली, व्हाट इज दिस शेप? This is not a 2-dimensional shape, this is a 3-dimensional shape actually, and this is a sphere inside a cube. इस शेप की बात करो, so what is this? This is a, आप लिख लो, अलग से लिख लो, that this is a sphere inside a cube, and drawing these objects is going to take was going to take some time. That is why इसको मैंने पहले से बना लिया to save some time. कोई फर्क नहीं पड़ता आपको उससे, है ना? And okay, so I have some more examples. Apart from this, I have a set of, I guess, 5-6 examples apart from this. तो सारे ले लेंगे और इतने एग्जांपल्स कराऊंगा कि आपका व्यू फैक्टर्स का कोई डाउट नहीं बचेगा. गेट में तो यार व्यू फैक्टर का क्वेश्चन आपसे आराम से सॉल्व हो जाएगा इफ इट इज देयर. हर बार नहीं आता, समटाइम्स यू हैव बेसिक क्वेश्चन ऑफ कैलकुलेटिंग हीट ट्रांसफर रेट बाय रेडिएशन इन गेट. ओके, सो दिस इज अ स्फीयर व्हिच इज प्रेजेंट इनसाइड द क्यूब. ओके, दिस एंटायर सरफेस, कई बार स्टूडेंट मुझसे कहता है कि सर आपने इस पे एरो मार्क किया दैट दिस इज सरफेस 1, सो दिस इज सरफेस 1, व्हाट अबाउट दिस सरफेस? ऐसा नहीं है, दिस इज सरफेस, दिस एंटायर सरफेस ऑफ द क्यूब इज सरफेस 1. ओके, and this entire surface of this, okay, entire surface of the sphere is surface 1, sorry, I said cube earlier, and the entire inner surface of the cube is surface 2, and the length of the cube is equal to the diameter of this. वो ऐसे भी टच कर रहा है तो obviously ऐसा होना ही चाहिए, L is equal to D. So I have a sphere inside a cube. आप लोग वीडियो पॉज करो and try to find out F12 and F21. Let me tell you how I'm going to solve this. I'm going to make use of all those rules that I have discussed so far. Okay. So first of all, let us talk about the symmetry part, right? Let's talk about the symmetry, that how we are going to solve this. Okay, so yeah, you can see here that for this surface, for the surface 1, the surface 1 is convex, of course, है ना? Surface 1 is convex according to the example that I gave you in the self view factors. So definitely F11 is equal to 0, right? But F22 is not equal to 0. Because this is the 2-2 surface, this is the 2-2 surface, right? The surface leaving this, the radiation leaving this surface may strike this surface, and this surface is also. अब बोलोगे सर क्या मैं इसको 2, इसको 3, इसको 4, इसको 5 ऐसा बोल सकता हूँ? Yes, you can, right? Okay, but I have named this entire surface as the surface 2, so F22 is not 0 definitely, because the radiation leaving this surface can strike this surface. F11 is 0 definitely. Okay, now let us talk about some other correlations. How F11 is this, and I know that this is also an enclosure, right? It is enclosure or not? Yes or no? So F11 plus F12, because there are two surfaces only, so F11 plus F12 must be equal to 1. Right? From here, I get that F12 is equal to 1. It is obvious also. This is surface 1. Surface 1 से जो भी रेडिएशन निकलेगी कहाँ जाएगी? 2 पे ही तो जाएगी, because मैंने इस पूरे surface को 2 कह दिया. अब जो भी रेडिएशन, whatever radiation is leaving surface 1 will be striking either this surface, this surface, this surface, this surface, this surface, this surface. So it means F12 must be equal to 1. Right? If this is the scenario, तो F12 find करना था, वो तो आ गया. Now I have the reciprocity relation. Right? That says A1 F12 is equal to A2 F21. I have scarcity of space, so जो भी जहां भी स्पेस है मैं वहां पे क्वेश्चन को सॉल्व कर दूंगा, आपको आसानी से समझ आ जाएगा, डोंट वरी. व्हाट इज द एरिया फॉर अ स्फीयर? इट इज 4 पाई r square, right? Or you can say 4 pi d. So 4 pi r square is d square by 4, so I think it is pi d square, right? 4 pi d square by 4 pi d square. Whenever you are solving exam, whenever you are doing some calculation in exam, many times we are overconfident. हम क्या करते हैं कि सर ऐसे ऐसे ऐसे, इसमें मेरी बात मानो, इसमें गलती होती है. मेरे से यहाँ क्लास तक में गलती हो जाती है when there is no pressure. ठीक है, तो आपसे भी होती है. So make a habit that even if it is a small calculation, try to do it on that rough paper provided to you in the exam. ये हैबिट बनाओ, ये हैबिट वाली बात होती है. ऐसा नहीं कि नहीं सर अभी काम करो, उस समय कर लूंगा. एक्चुअली आपकी हैबिट में आ जाता है. जब आपकी हैबिट में आ जाता है दैट यू डू द स्मॉल कैलकुलेशंस इन ऑन योर फिंगर्स विदाउट राइटिंग देम, वो हैबिट वहां भी फॉलो होती है एंड फिर आप उसको छोड़ नहीं पाते हो. ठीक है, एंड देयर यू मेक मिस्टेक्स. तो मेक अ हैबिट. आप बोलोगे सर उसमें टाइम लगेगा, तो उसी टाइम की तो प्रैक्टिस करनी है ना, उसी टाइम को तो शॉर्ट करना है. वही तो प्रैक्टिस है. टेस्ट सीरीज किस लिए दी जाती है? उसी टाइम को शॉर्ट करने के लिए दी जाती है. टेस्ट सीरीज इज नॉट फॉर ऑलवेज लुकिंग फॉर न्यू क्वेश्चन. नहीं, टाइम छोटा करो, टाइम शॉर्ट करो. कुछ कैलकुलेशंस ऐसे डेवलप करो. आप बोलोगे सर आप शॉर्ट ट्रिक्स बता दो, तो ये पॉसिबल नहीं है. फिर तो मैं हर क्वेश्चंस के लिए शॉर्ट ट्रिक्स ढूंढता रह जाऊं. दैट इज नॉट पॉसिबल. यू डेवलप योर ओन शॉर्ट ट्रिक्स, शॉर्ट कैलकुलेशंस. ठीक है, ये करना है तो इसके बाद मैं सीधा 1-2 स्टेप के बाद सीधा डायरेक्ट इस पे आ सकता हूं, है ना. चलो, सो पाई डी स्क्वायर मल्टीप्लाइड बाय F12 व्हिच इज इक्वल टू 1 इज इक्वल टू A2. व्हाट इज A2? A2 6A स्क्वायर होता है ना. A स्क्वायर 6A square. What is 6A square? 6L square. What is that? 6D square. L is equal to D into F21. अब यहां से D square कैंसिल, और जो आपकी F21 की वैल्यू आ रही है that is pi by 6. Must be less than 1. Correct? So F21 and F12 for this sphere inside the cube that we can find, and definitely if I ask you that what is F22, so F22 must be F21 plus F22 is equal to 1. So F22 can be found as 1 minus pi by 6. Right? So that was one case. Now this secondly is what is this? आप पूछोगे सर ये क्या है? This is also 3-dimensional shape. This is a triangular duct. Triangular duct. Duct समझते हो? Duct means pipe. Pipe नहीं कहेंगे. Pipe is having a circular cross section. Now the duct can have any cross section. Can be triangular, can be equilateral triangle, can be isosceles triangle, can be rectangular duct. This is a triangular duct. मतलब इसकी length है कुछ. Okay, this L is L. Okay, inside the board it is having some length. You can assume that length to be equal to 1 W L Z, doesn't matter. Right? वो चीजें cancel हो जाएंगी. Right? Suppose that the inner length of this is W. आप उसको, अच्छा ये L है, ये L है, आप ये डायरेक्ट लिख सकते हो ना. This is √2L. इसमें कोई दिक्कत तो नहीं है ना. Mathematics, बहुत basic mathematics. Okay, now I have to find. Okay, if I ask you that okay, what is this is first surface, second surface, third surface, right? F12 find करना है. If I ask you that in this case, what is F11? You'll say 0. F12, okay, we'll talk about that later. F22 is equal to 0. ये inspection से मैं बता रहा हूँ. F33 is equal to 0. Normal inspection, okay. Now after this, you can see here that for this surface 1, surface 3 and surface 2 are symmetrical. For surface 3, this and this, they are not symmetrical because इनकी orientation अलग-अलग है. For surface 2, these are not symmetrical. दोनों की orientation अलग-अलग. But assume yourself that you are the diagonal. Sorry, this is called diagonal? नहीं, this is called hypotenuse. Huh? So assume that you are hypotenuse, and for you, ये side और ये side बिल्कुल एक ही जैसी orientation है. So for this surface 1, surface 3 and surface, this is one more example of symmetry. For surface 1, surface 2 and 3 are symmetrical. Surface 2 and 3 are symmetrical. ये समझ आया? सरफेस 1 के लिए सरफेस 2 और सरफेस 3 सिमेट्रिकल है, ठीक है, बट इट इज नॉट मैंडेटरी दैट इफ दिस एग्जिस्ट देन फॉर सरफेस 2 आल्सो सरफेस 1 एंड सरफेस 3 इट्स नॉट मैंडेटरी. यू हैव टू इमेजिन दिस सिचुएशन दैट यू आर द हाइपोटेन्यूज. अब देखो ना, अगर आप ऐसे लेटो तो जैसी इसकी ओरिएंटेशन होगी वैसी उसकी होगी, बट अगर आप ऐसे लेटो तो ये अलग एंगल पे है, ये अलग एंगल पे है. ओके, सो देयरफॉर आई कैन से दैट F12 must be equal to F13, right? Also ये सिमेट्री हो गया फ्रॉम समेशन रूल. F11 प्लस, देखो कितने आसानी से आ रहा है, F12 प्लस F13 इज इक्वल टू 1, ठीक है. सो 11 इज 0, 12 इज इक्वल टू 13, सो F12 एंड 13 कितना आ गया, F12 13 इज इक्वल टू 0.5. दैट हैज टू बी इक्वल एंड दैट सम इज इक्वल टू 1. सो 12 और 13 तो हो गया, 12 फाइंड हो गया. Now I want to find 2, 1. So let us use the reciprocity relation for this particular case. कहाँ लिखे देखते हैं, यहाँ लिख लेते हैं. Okay. Don't have space here. अच्छा, ऊपर वाला आप इरेज कर दे, ठीक है. आई होप आपने लिख लिया होगा. पॉज कर लो, लिख लो नहीं तो, है ना. Now let us use the reciprocity relation for this case. A1 F12 must be equal to A2 F21. Correct? Let's see. So what is area of 1? This is a duct. Duct is made up of rectangular plates. So this area will be length or this side into the length inside the board. उसको आप unity मान लो, कोई फर्क नहीं पड़ेगा, कैंसिल हो जाएगा. So √12 मान ले इसको एरिया को, √12 multiplied by 1. So √12 multiplied by 1, that is the area 1. And F12, what is F12? 0.5 is equal to A2. What is A2? L into 1, right, multiplied by F21. So L cancel and F21 comes out to be 0.5 into √2. So √2 divided by 2, so 1 by √2. और 1 by √2 कितना होता है, ये वैल्यू आपको याद होनी चाहिए. याद क्यों, क्या करोगे, वैसे भी कैलसी होता है हमारे पास, है ना. So 1 by √2 is 0.707. Now you know F21, what is F22? 0. मैं सारे निकाल दे रहा हूँ ना. F21 is 1 by √2, so F21 plus F22 plus F23, because this is also an enclosure. Enclosure में समेशन लगेगा, समेशन ऐसे नहीं लगेगा, enclosure में लगेगा. F21, F22, F23 is equal to 0. So F21 I have 1 by √2 plus 0 plus F23 is equal to, this must be equal to 1. So F23 is equal to 1 minus 1 by √2. सॉल्व करते रहो, निकालते रहो व्यू फैक्टर, अच्छे क्वेश्चंस बन जाएंगे इन पे, ठीक है. सो दैट इज दे वर 2 एग्जांपल्स एंड दोनों रूल्स का, सिमेट्री का, समेशन का, दोनों का यूज हुआ. रेसिप्रोसिटी का भी यूज है. सिमेट्री, समेशन, रेसिप्रोसिटी, दीज 3 विल बी फ्रीक्वेंटली यूज्ड. लेस फ्रीक्वेंटली यूज्ड आर ओके, सेल्फ व्यू फैक्टर आल्सो आई हैव यूज्ड. लेस फ्रीक्वेंटली यूज्ड इज द सुपरपोजिशन, ठीक है. और इसके अलावा अगर किसी बुक में कुछ और यूज हुआ है तो वो आपको नहीं पढ़ना है, स्किप कर दो सीधा, राइट. ओके, now let's talk about what is view factor matrix. All of you know the basics of matrix. ये मत कहना कि सर पढ़ाया नहीं अभी तक, है ना. बेसिक ऑफ मैट्रिक्स सभी को बता रहा. इन मैट्रिक्स how many surfaces are there? 2. So you can make a matrix like that, 2 into 2 matrix. How are you going to write the elements? Fij, Aij, तो F11, F first of all row and then column, row column, F row column, बन गया फैक्टर मैट्रिक्स. आप बोलोगे सर why only 4 elements? Because there are 2 surfaces, 2 square, 3 surfaces, 3 square, 9 elements in that case. Okay, so this is coaxial cylinders. For the outer layer I have only made only this side half, that side half is also there. Don't think that it does not exist. बना ही देते हैं, otherwise you will be confused कि surface नहीं है. This surface is also there. Okay, and then the inner surface, this is shaded part. So this upper surface of the inner tube is taking part in the radiation, and inner surface of the outer tube is taking part in the radiation, and the outer tube is surface 2 and this is surface 1. Radius relations are given to you. So all of them, okay. First surface is a convex surface. So by inspection I know that F11 is equal to 0, right? Also F11 summation rule, F12 is equal to 1 and therefore F12 is equal to 1. तो ये तो पता लग गया F11 कितना है, 0, ये 0 है, ये 1 है ना. Okay, now let's talk about A1 reciprocity relation. F12 is equal to A2 F21. Fine. So what is A1? Area of surface 1, 2 pi RL, right? So 2 pi surface area is used, है ना? 2 pi R into L into F12, that is 1. What is A2? 2 pi R, which is twice of R, into L into F21, correct? 2 pi cancel, RL cancel, F21 is equal to 0.5 और F21 0.5 होगा तो F21 plus F22 is equal to 1 and that must be equal to F22 is also equal to 0.5. तो आपने यहाँ पे ये सारे मैट्रिक्स बना लिए, क्वेश्चन सॉल्व हो गया. ठीक है, बहुत छोटे छोटे क्वेश्चन है, दैट इज व्हाई आई डिड नॉट टेक ऑल ऑफ दीज एज अ सेपरेट क्वेश्चंस. ओके, नाउ दिस इज आल्सो अ डक्ट, बट डक्ट ऑफ शेप, एक ऐसा केक में से आपने एक पीस बाहर निकाल दिया. नाउ व्हाटएवर इज रिमेनिंग, बट इट इज आल्सो हैविंग सम लेंथ इनसाइड द बोर्ड, दैट इज गोइंग टू बी कैंसल्ड एनी हाउ, राइट? सो इन दिस केस, हाउ टू फाइंड दिस the final the result F12 F21, you guys can try to solve this problem, right? So this is a area 2 is given to you, area 1 is given to you. Let me clarify first that this angle is 90 degrees, so that part is not there. Only this surface, okay, I'm saying that this surface is 1, I'm talking about both the surfaces, right? And here the radius is also R, you can write down that the radius is R, okay? I'm talking about both the surfaces. Both the surfaces together, they are called surface 1 and this entire surface is surface 2. Okay, so what do you think about F11 in this case? F11 should be non-zero or 0. Self-view factor of surface 1. This is surface 1, this is also surface 1. F11 is equal to 0. Now, you know the rules, okay? Also, this is an enclosure. Everything is an enclosure here. तो मैं summation rule कहीं भी लगा सकता हूँ, right? Also, F11 plus F12, this is surface 1, must be equal to 1. Therefore, F12 is equal to 1. समझ आया, है ना? F12 की वैल्यू 1 आ गई. Now, what we want to find? 1 2 तो फाइंड हो गया, F21 फाइंड करना, तो ठीक है. नेक्स्ट रिलेशन इज रेसिप्रोसिटी. सो A1 F12 must be equal to A2 F21, correct? Now what is A1? This area. Suppose the length is L. And this is R, so R into L is the area. For this also R into L is the area. भाई ये कैसे दिखेंगे? रेक्टेंगुलर दिखेंगे ना? This is a duct. It has some length. So L को आप चाहो 1 ले लो, doesn't matter. Area is for surface 1 it is R into L plus R into L. So that is 2 RL into F12, which is 1. What is area of 2? Surface 2. See, you can say that surface 2 is a cylinder from which this much portion has been removed. So what is the area for a cylinder? 2 pi RL. So पहले तो ये लिख लो, 2 pi RL. Are you getting this? 2 pi RL is the area of the entire cylinder. अब inner cylinder का area लूँगा या outer का, we have to take same area. Out of that, we have removed, because this is the second surface only, this is the first surface. If you talk about A2, A2 is this surface. इसमें से आपका 90 डिग्री पार्ट मींस 1/4 पार्ट रिमूव हो गया. दिस एंटायर एंगल इज 360. 90 डिग्रीज मींस 1/4 पार्ट हैज बीन रिमूव्ड. सो व्हाट इज लेफ्ट? 3/4. ओके, बेसिक ज्योमेट्री इनटू F21. तो थोड़ा अगर समझ नहीं आया तो थोड़ा सा इसके शेप पे आप विचार करना, थोड़ा सोचना इस पर, राइट? 2 RL एंड 2 pi RL. सो RL 2 2 2 2, राइट? F21 इज इक्वल टू पाई भी गया क्या? नो, F21 is coming out to be 4 by 3 pi. 4 by 3 pi. Okay, let us solve this. This will give you the value. Okay, 4 divided by 3 pi, and it is coming out to be 0.424. That is the correct answer. Okay, 0.424. You can see and how easily you can solve the view factor problems. So these are some examples. Now I will include some more example, 2, 3, or 4 more examples, so that the concept of shape factor will be further clear. Another example is there is a solid sphere which is enclosed in a hemisphere, right? So such that the area of this hemisphere, the surface area of the hemisphere is twice of the area of this sphere. A2 is equal to 2A1. So थोड़ी सी language लिखे यहाँ पे, that is small sphere of area A1 under a concentric hemisphere. So how to solve this problem? I have taken similar kind of problems, this problem, and this problem. दिस वन इज स्लाइटली डिफरेंट, ठीक है। तो इनको सॉल्व करने का तरीका आप देखोगे दैट हियर आई एम ट्राइंग टू मेक an imaginary surface which is actually not existing there, but I'm trying to make an imaginary surface, right? Just complete this hemisphere like this. Complete this hemisphere and consider that this part of the hemisphere is the surface 3. You can consider like this, right? You can consider like this and then solve the problem. Okay, so A2 is equal to 2A1. Now I have completed the hemisphere. The hemisphere, I have completed the external sphere also. So actually it was a hemisphere, but I have created an imaginary surface. I will use that surface for writing all those equations, summation rule. Obviously, na apne bahar ka surface complete kar diya. Now it has become an enclosure, right? So let us talk about this. Of course, F11 by inspection is equal to 0. How many surfaces are there, right? So this is the entire surface. Okay, what do you think? What else we can write? Of course, for surface 1, I can write F11 because this has now become an enclosure, right? So F11, F12 plus F13 is equal to 1. Chalega? Now F11 is 0 in this case, right? Similarly, that is the summation rule. That is the self-view factor. Now what do you think? That suppose if this is a separate surface, this is a separate surface. 1/2, 2/2. अब अगर आप अपने आप को assume करो that you are this sphere, how this half and this half is going to look like? They will be alike to you. One will be on the left side, one will be on the right side, but they will be like that, exactly symmetrical. Same position, same orientation. So definitely the radiation leaving the surface 1, half part of this will strike surface 2 and half will be strike surface 3. So I can say that by symmetry, F12 must be equal to F13. Symmetry. This is equal to 0. F12 plus 13 is equal to 1. They are equal, so therefore they must be equal to therefore F12 find क्या करना था, पता नहीं क्या find करना था, सारे find कर देते हैं. F12 is equal to F13 is equal to 0.5. So I have applied symmetry, summation and inspection, self-view factor. After this, of course, you can apply the rules of symmetry, reciprocity theorem. And what do we have to find actually? The reciprocity theorem says that A2 F21, because F21 we have, no, we don't have, no problem. But A1, I'll solve this problem later, don't worry. A1 F12 must be equal to A2 F21, correct? Right? So in this case, what is area of 1? The surface area, 4 pi r square, right? So, right, in this case, oh, okay, it is given A2 is equal to twice of A1, so not required. आप directly यहाँ पे क्या put कर सकते हो? A1 into F12, which is 0.5, is equal to A2, which is twice of A1 multiplied by F21. Correct? Fine. So from here you can see that what is getting cancelled? A1 is getting cancelled, and F21 will be equal to 0.25. Right? After that you can apply F21, F22. Of course, F22 is non-zero in this case, and then F23 will also be something. ठीक है? तो जितने व्यू फैक्टर्स आपको पता, बिकॉज थर्ड सरफेस वाज नॉट एग्जिस्टिंग, राइट? सो दे वर नॉट आस्किंग यू टू फाइंड F23. आपके लिए तो दो ही सरफेस थे, so F12, F21. So don't try to find F23 or F32 in this case. It is possible that you won't be able to find because of less information is there, right? हो सकता है in that case आपको वो values directly provide की जाए. And the second thing is third surface is not existing in reality. I have just imagined a third surface so that I can apply this summation rules. ठीक है, तो इसको मैं इरेज कर रहा हूँ, आप इसको नोट कर लेना. आई होप यू वर एबल टू सॉल्व. ओके, सो दिस वाज वन डिफरेंट काइंड ऑफ प्रॉब्लम्स वेयर आप देखो आपने एक इमेजिनरी सरफेस अज्यूम की एंड यूजिंग दैट इमेजिनरी सरफेस यू फाउंड द व्यू फैक्टर, राइट? सो आई हैव ट्राइड, दिस इज अ लॉन्ग डक्ट, यहाँ पे लिखा था लॉन्ग डक्ट. ओके, आई हैव ट्राइड टू इंक्लूड वेरी गुड प्रॉब्लम्स बेस्ड ऑन दिस व्यू फैक्टर्स. आपको ये इतनी अच्छी प्रॉब्लम्स, इनमें से कोई भी प्रॉब्लम आपको गेट केमिकल में तो नहीं मिलेगी, ठीक है? ऐसी प्रॉब्लम्स ले लिए मैंने, ठीक है? तो अगर इससे इस लेवल की प्रॉब्लम्स अगर आपको आ जाती है देन डेफिनेटली यू विल बी एबल टू सॉल्व. और सीधी बात है, व्यू फैक्टर की अंडरस्टैंडिंग अच्छी होगी आपकी देन, ठीक है? सो लेट अस टॉक अबाउट दिस. दिस इज अ लॉन्ग डक्ट एंड वी हैव टू फाइंड F22. सो इन दिस केस I think I have not provided which area is area 1 and which area is area 2. So this area, it must be provided actually, and this area is F22. This is area 1 and this is area 2. Fine. And of course, in this case, radiuses are, that is not a problem. You can always assume that the radiuses are. Fine. By inspection, you know that F1 is the flat surface, so F11 is 0. F11 plus summation rule, because it's an enclosure, that is equal to 1. So F12 is equal to 1. Quite easy problem, right? Now A1 into F12 must be equal to A2 into F21, correct? What is A1? This surface. This is a duct, so it has some length inside the board. So R into L into F12, that is equal to 1. And this is what? This is the surface area of a cylinder, because the duct will be of cylindrical shape, right? But half of the cylinder. So half, what is the surface area? 2 pi RL or pi DL, right? Let's write in the form of R, not a problem. Half of 2 pi RL and that multiplied by F21. You can see yourself that RL is getting cancelled. RL 2, F21 is equal to 1 by pi. And therefore, F22, we have to find F22, right? 1 minus 1, because F22 is not 0, it is the concave surface, right? 1 minus 1 by pi. So, pi minus 1 divided by pi. So, decimal mein kya values aayenge, you can calculate, right? This can be written as, so F21 is coming out to be, F21 was what? This is R, okay. This is 2R, sorry. This is 2R, right? 2R into L. So, F21 was 2 by pi, right? Yeah, F21 was 2 by pi and therefore F22 was 1 minus 2 by pi. So, ye values aap dekh lena, right? What is 2 by pi and what is the value of 1 minus 2 by pi? That definitely you can calculate, right? So, that was another very beautiful problem based on view factors. Now, consider this one. These are two plates only two surfaces are there, correct? Now again, I'll try to make it an enclosure by assuming a third surface which will be imaginary, which is not existing in reality. These are long plates, means the length of the plate is in the direction of inside the board, but this orientation of plate is a special orientation where this length is 200 millimeters, means 20 centimeter, and this height is 100 centimeters, means 10 centimeter, and this point B is exactly at the top of the midpoint of the plate A1. Means if I make an imaginary surface like this, let us remove this line to avoid any confusion. I'm just considering a third surface here. This third surface is not present in reality, but for solving the problem, I'm considering a third surface, right? So what we can say, just by basic inspection, I can say that F11 is equal to 0. Kya find kya karna hai yahan pe? Everything, all the view factors we have to find. Okay. F11 is equal to 0, and this is these are long plates. So suppose they are having some shape, some length inside the board, suppose L. F11 is 0, and by symmetry you can see that this is 200 and this is height is 100, right? So this side and this side, I hope all of them are equal. This is an isosceles triangle or equilateral triangle. What do you think? The side is height is actually 10 centimeter, and the base of the triangle is having a length of, right? The base of the triangle is having a length of 220 centimeter, and the height is having the length of 10 centimeter, right? So F11 is equal to 0, the self view factor, and thereafter I can write F11 plus F12 plus F13, right, is equal to 1. So enclosure, देखो summation rule हमेशा enclosure में apply होता है, and to make this an enclosure, what I did here, that I assumed a third side, right? Definitely it is equal to 0, right? Now can you see any symmetry here? By symmetry, यहाँ भी मैंने symmetry का use किया था, but मैंने लिखा नहीं है ना. You should know that, not in this problem, in the previous problem. Can you see any symmetry here? What do you think? For this surface 1, again, I think a rectangular duct problem we have just solved a few problems before. For the surface 1, surface 2 and surface 3 are symmetrical. Because it's an isosceles triangle, I think. You can go through the basic geometry of this. This is an isosceles triangle. So by symmetry, F12 is equal to F13, right? And because the summation equal to 1, both of them must be equal to 0.5. And after this, I think the only thing that is remaining is the application of reciprocity theorem, which says A1 into F12 is equal to A2 into F21. Correct? So, what else? What is the area of the surface 1? That is 20. I can write in the centimeters. 20 into L into F12. F12 was equal to 0.5 is equal to area 2, which is, this height is 10, right? So you can find the value. It is exactly in between. So this will be 10. This will be 10. correct? This is 20, so okay, 10. So what will be this? Root of 10 square plus 10 square, right? So that is, I think, 2 root 10. L 2 root L, root 2L actually. So that A2 becomes root 2, and this is 10. This is 10. So root 2 into 10. That will be the length of this side multiplied by L into F21. I think calculations are correct. L will be cancelled, right? 10, 2 into 0.5 is 1, and F21 will be 1 by root 2. I think F21 will be 1 by root 2. You can check your calculations. Okay, so F21 is coming out to be 1 by root 2, which is equal to 0.707. Now, can you guess that how to solve this one? Again, you can see that these are sphere lying on infinite plane, means the length of the plane is infinite. Now, if it is infinite, you can't talk about the length of the plate is equal to L. Now, again, in this case also, I'm going to assume a third surface. And this third surface is imaginary, right? Let's say that this is third surface having area A3, and this is also infinite. Third plane is also infinite. What we have to find here? In this case, I think also we have to find F21, right? F21 we have to find. So, think about this. This is surface 1. Of course, this is convex surface, so F11 is equal to self-view factor is equal to 0. The self-view factors of F22 and F33 should also be 0. Correct? Now, if you consider these two planes, they are infinite. For this sphere, if you imagine yourself as this sphere, this plate as well as this plate, they are symmetrical. So, I can say that F12 must be equal to F13, right? And this is an enclosure. अब बोलोगे सर enclosure का है, यहाँ तो कोई surface ही नहीं है. These are infinite plates, so definitely I can think of this as an enclosure. Therefore, F11 plus F12 plus F13 must be equal to 1. They are equal. From here, I have this relation. Therefore, F12 is equal to F13 is equal to 0.5. Right? What about F21? Reciprocity relation. No other relation is remaining. So, A1. What is A1? Infinite. Okay. A1 into F12. What is F12? 0.5 is equal to A2 into F21. Correct. So, A1 is, you can take some area, right? Not a problem. So, F21 will be, from here you have F21 is equal to A1 by A2, A1 by A2 multiplied by 0.5. Now, A2, what is A2? A2, infinite plate, so infinite area, right? Okay, infinite plate, infinite area, and therefore some finite area by infinite area must be equal to 0, and therefore F21 must be equal to 0. Right? Yeah, F21 must be equal to 0. Correct? So, these were some special problems on view factors. Chemical में इतना नहीं आता, but these kind of questions have been asked in mechanical engineering. Some of them have already been asked, like this one, and previously there was sphere inside a cube. You can always expect that these kind of questions can also be asked in chemical engineering. ऐसा बिल्कुल नहीं है कि सर ये तो बस mechanical में आते हैं, हमारे में नहीं आता, ऐसा बिल्कुल नहीं है. You never know कि किस साल ये problems उठ के आ जाए. लेकिन अब view factor में ये problems भी नहीं कराएंगे तो क्या करेंगे, right? This was the entire thing about view factors. अब इसके अलावा आपको और view factor में कुछ पढ़ने की जरूरत नहीं है.